Hello and welcome back to my channel. Today we're at question number 196 for DevOps and SRE interviews. The point of these videos for me is to get you ready as ready as possible for a DevOps or SRE interview that might be coming up for you. I've tried to cover the top 15 topics that are the most important in as much depth as and width as possible. That way, when you walk into an interview or on a Zoom call, you feel like you were ready or as ready as you possibly could be for that interview. If you're new to the channel, please subscribe. It's nothing for you, but it makes a big difference in my channel. So please do that, and I would really appreciate if you did that. Okay, so these are the 15 topics, as you might know from other videos, that I've come up with based on data from LinkedIn job descriptions that are the most important to cover and study for DevOps and SRE interviews. The ones at the top are more important than the ones at the bottom, obviously, but even the bottom ones come up a lot, so please don't ignore them. But I'll obviously focused majority of your time in the first 5 or 6 topics that are on the screen today. So today we're at number, I don't know why it says number 1. It should say number 7, Linux. Topic number 7, Linux is our topic today. So the question is, can you explain the concept of copy on write and in the Linux kernel, and how does it work, and what would be a good use of this, like what a use case for this idea, right? Here the interviewer is looking for your depth of your knowledge of Unix. Generally speaking, if we haven't worked with Linux for a long time, you may not know about kernel stuff, and you may not know about copy on write. So and then they will show that you don't know that. Now this topic is a little bit not so much advanced, but really it's okay if you don't know this. Basically, what I'm saying. It took me a long time to even study this stuff, and I've been doing Unix for the last 27 years. So it is okay if you don't know this, but it'd be good to know about Linux kernels just a little bit, and in case well, Linux will come up no matter what, but this particular topic may or may not be. So, a quick reminder to take advantage of my career advisor, Floyd Spencer, and I'm not affiliated with him financially, so this is not an ad. It's just that he is very passionate. So please get the 1 hour free session that he is offering right now. Okay, so first of all, what is copy on write, right? So what it means is when um, Unix kernel decides that it is time to write a change a memory location, right? It basically waits until the very last moment to do it, when it has to do it. By delaying this process, what it does, it makes the Unix machine more performant, and it uses less memory, if you will, because you're not at any given time. If you're doing as little writing as possible, then the transactions between the CPU and the memory would be as fast as possible, right? So you're not locking. It's like you're not clogging up the highway for writing, because writing is a lot more expensive than reading, obviously, from memory. So when can you use this? When is it used? First of all, forking. So I don't know if this is another topic, good topic to know. If a lot of times a Unix machine will fork a process, means it will create two processes from one. When it does that, it actually makes a copy of the memory that is used, memory that's used by the first process, right? So as you can imagine, a whole process memory could be significant in terms of RAM. So it doesn't actually make the copy until it is absolutely the last moment to do it. So that's an example of copy on write. Um, so what that means really is, until the second process makes a write, or even the first process for that matter, it doesn't actually make the copy, right? When a write request comes through, only then it makes the copy. A second example of that would be very common in virtualization and containerization, meaning, let's say a good example would be Docker, right? Docker is using memory maps all the time between different containers. So unless it really has to make a copy of a particular memory address, is going to wait till the last minute to do it. The other one is, by using this process, right, Linux can actually overcommit the amount of RAM that it has. So let's say that we have 2 gigs RAM, right? And maybe 1 gig of that is, I'm just making numbers here, 1 gig of that is actually used for user processes. It might actually say that I have more memory available than I really do, because some of the memory could be kind of be on hand, if you will, because the actual writing hasn't happened yet. So once you write, then only then is the memory is actually being used. So you can Linux can make more memory available than it really has in underneath. So that would be another way of another use case for this. Hope this was useful, and if you have particular questions or further questions, you can find me on LinkedIn, or you can just leave a comment down below, and I will see you next time.